Good everyone, I welcome you back to Global Education Zone. And today in this episode, we are going to be talking about another topic in mathematics for SS1, which is logical reasoning. And today we are going to be taking the first class in logical reasoning. Logical reasoning is rather a large and wide topic, but this is going to be the first and the most fundamental class in logical reasoning. So, if you are going to understand logical reasoning and the subsequent videos on it in mathematics in this channel, you have to watch this one completely. So today we are going to be talking about open and closed statements. We are going to be talking about conjunctions. We are going to be talking about disjunctions. We're talking about equivalence, implication, and other connective. These are all known as connectives. So in a previous episode, but not in mathematics, in the English classes we'll be having in this channel, I talked about the fact that there are four different ways we can use we can communicate in English. We can make use of statements, we can make use of questions, we can make use of sentences. So all these, there are four different types of sentences. If you watch the video on sentence in this channel, I talked about four classes of sentences. There are ones that are statement sentences, there are question sentences, there are command sentences, and there are exclamatory sentences. Now in logical reasoning is just the way we express ideas, and those ideas are either true or false. So in this expression of ideas, we'll make use of statements, and these statements can either be true or false. And these statements that are either true or false, they are well defined. Now in previous videos on set, we talked about set as being a collection of elements that are well defined and can have a distinguishable property, right? Now in this video we're talking about not sets now, but logical reasoning. And in logical reasoning we're talking about statements, and these statements, they form arguments, they form compound and proposition. So these statements, they combine together to form propositions, and these propositions can combine together to form logical propositions and compound propositions. That is when you arrange one or more sentences to form a proposition, and then you arrange those sentences to form an argument or a chain rule. Now these are advanced things in logical reasoning. They are not very advanced, but they are beyond this video. We'll be talking about this in another video, but today let's talk about the beginning of logical reasoning, where we'll be talking about open and closed sentences, conjunction, disjunctions, equivalence, and all the rest. Now first of all, for we to consider anything a logical argument, it has to be a closed statement. And if it's an open statement, it is not going to be logical. For example, if we say they are black, if we call this statement 1, they are black, and then we'll have statement 2, I am black. Now there's a difference between these two, because in the first one the sentence is they are black, but now the person who makes this sentence doesn't tell us who exactly is black, but it just says they are black. Now any statement like this is a statement because it's declaring something. This is a declarative sentence, also known as a statement. And these declarative sentences, these are both declarative sentences, but one is open and one is closed. The one that is open is the one that does not tell us enough information about the object or subject of the sentence. So it is the one that is not definite. So this one that says they are black. Who is black? Who exactly is black? So this is an open sentence, and it does not characterize logical reasoning. But the second one, which is I am black, there's a specific person who is black, which is me, right? So that means you can successfully say that this is a closed sentence because it has a specific and well-defined object or subjects you are talking about. So this is the first one is open sentence and the second is closed sentence. So I hope you understand that analogy now. Now moving on, when we have all these closed sentences, which is number 2, we will not be dealing with number 1 anymore. Let's be dealing with number 2. So with this number 2, we have the truth value of a statement in logical reasoning. Now the truth value is basically whether that statement is true or false. So whether this open statement is true or false, it gives us its truth value. Now if you've seen me before real life, just as you are seeing me in this video now, and you can testify that I am actually black, then the truth value of this statement will be true. But if actually I change my color and I become light, and then I make this statement, you can know that you can say it's false, right? So that means the truth value of this statement will be false. That is simply what truth value of a statement means. And this simple combination of open statements and truth values is what we use to form different logical arguments in mathematics. And these logical arguments are not just used by mathematicians, they are also used by philosophers. When you study philosophy, you make use of compound propositions to make an argument and to test the validity of a particular statement. So now, moving on, let's talk about the relationship between these arguments or these statements. And these statements are related together in what is known as connective. Now we have different connective for our statements. But before that, let's talk about compound statements. Compound statements are connected together as simple statements connected together by one or more connectives. So the first one we're talking about is conjunction. So conjunction is a connective and. So if I say I am black. Now if I call this statement A, and I'll say number 2, my statement B should be I like rice. This is my statement B. Now if you look at these two statements, the first says I am black, right? And the second says I like rice. Now if I want to make these statements combine into one, I want to represent them in just one logical reasoning. Now I will combine it together with a connective, and the connective I will use is the and connective. So I will represent this in symbolic form as A. Now A and B is simply A this B. So this is symbol for I am black and I like rice. So when you connect this one by and, if I say I am black and I like rice, this means the meaning of this A and this symbol, this that looks like an inverted V connecting with B, it means I am black and I like rice. Now, but in another case, if I want to say that it's not possible for me to be both black and like rice, so either I'm black or I like rice, or either I like rice and I'm not black. So now I will use a connective, and that connective is called disjunction. This inverted V connective is called a conjunctive connective. So it is A and B. So, but if I want to say I am black or I like rice, if I replace it by or, this will be the connective. I will use A and the V and B. So this means A and B. Why this means A or B? So this is, if A is I am black and B is I like rice, then A and B will be I am black and I like rice. That is represented mathematically in logical reasoning as this inverted V. That is for the symbol for and as a connective. Then next, if I'm connecting these two statements, these two close statements by or, that would be I am black or I like rice. That would be, I will use a V between the two statements. That would be A and this symbol and B. That would be I am black or I like rice, which is I am black or I like rice. So those are the two basic connectives we talked about: the connective of conjunction, which is and the connective of disjunction, which is or. Now let's move on to the next connective. Now, and note that this connective, whenever they are used in two simple statements or logical reasoning, they make them turn into compound statements or compound propositions. Now, moving on, we have other connective. Let's talk about those other connective. We'll talk about 3 more connective and use them in sentence. Then we'll talk about the truth values, the truth tables of each of these connectives. So let's move on with that. Now we have 3 more connective. The third one I'm talking about is the negation connective. And this is simply that connective that makes a statement, that changes the truth value of a statement. Now, if you have taken some computer science classes in either your high school or your college, you would have understood that in negation, in Boolean algebra, you will know that negation is basically when you have a true statement, a negation changes to false, and a negation changes the false statement to true. So negation basically changes the truth value of a logical reasoning or simple statement. For example, if I have a statement, let's still continue with the first statement, I am black. Now, and if this statement is called A, this statement A, now the negation of this statement is basically the second statement, and this will be I am not black. And it is represented by a wavy symbol before the name of the statement. So this I am black is A and I am not black is negation A. This is the symbol for negation in logical reasoning. So I hope you are taking some understanding of that. So now that is the negation symbol, and then next we have the conjunction. Sorry, I've talked about that. We have the equivalence and the implication. Now let's start from the implication. The implication statement simply means that if one thing happens, then another thing will happen. So that means if I give another statement, say if I have statement 3 as statement B as I like rice. This is statement B. Now I want to connect statement 1, I am black, with statement B, that's statement 3, I like rice. So we want to convert, we have to connect them with a connective, and this connective we want to use is the connective of implication. Now implication connective is basically the connective that states that if one thing happens, then another thing will happen. It's just like a consequential connective. So I want to say that I am black if I like rice. That means, or rather I will say, if I want to express if I am black, then I like rice. So how I will represent that is, if I am black, that will be first statement A, then I like rice. Then that then means, this is how to represent it. A implies B. That is an implication. Implication is also known as implies. So this means A implies B. When A means I am black and B means I like rice. So that means I am black implies that I like rice. Or you can also say if I am black, then I like rice. So that is the statement of implication. But if now we want to make another example, now we want to negate them. So we want to connect the opposite of these two. Now the negation of statement 3 will be I don't like rice. That will be number 4. I don't like rice. And that would be the negation of B. Now having this negation, if I want to connect the negation statement 2 of A with the negation statement 4 of B, then I'll say A, not A, implies not B. So that means this is simply read as if I am not black, which is not A, then this is symbol for implication, then or implies if I'm not black implies not B, I don't like rice, which is not B. So if I'm not black, then I don't like rice. So not A implies not B. If I'm not black, then I don't like rice. So this implication is just an if and then. If this, then that. If this, then that. If this, then that. So that is if and then. That is implication. Then we have equivalence. So equivalence means it's basically when you make use of your implication logical connective in both directions. So basically, if I make use of an implication, if I make use of an equivalence here, I would say not A is equivalent to not B. So the first one is an implication in that the arrow goes in just one direction, but not the other way around. But in an equivalence, the arrow goes in both directions. So not A implies not B, and not B implies not A. So it goes in both directions. So this arrow that goes in both directions is an equivalence. So this is the first one is implication, and the second one is equivalence. So this implication is read as if I'm not black, then I don't like rice. Then the second one is read as if I'm not black is equivalent to I don't like rice. Or you can also say if I'm not black, then I don't like rice. Then you can also read it the other way around as if I don't like rice, then I'm not black. Now each of these statements, this equivalence can be read in both directions and represented by a bidirectional arrow. There are many of equivalent statements that are natural now in mathematics. For example, the statement of an equilateral triangle. If you have an equilateral triangle here, an equilateral triangle is a triangle that has 3 sides. So if statement C is an equilateral triangle has equal sides, and statement D is an equilateral triangle has statement C is represented as equilateral triangle has equal sides, then if statement D is equilateral triangle has equal angles. So you can say that there's an equivalence here, because you can say if an equilateral triangle has equal sides, then it has equal angles. You can also say if an equilateral triangle has you can say if a triangle has equal sides, then it has equal angles. That's when you read this equivalent statement in the forward direction. Then you can also read it in backward direction. That means if a triangle has equal angles, then it has equal sides. That's because it's equilateral. Equal angles, equal sides. That is a by implication, or you can call it an equivalent statement. Now we've gone so far talking about the basic rudiments of logical reasoning. Now let's talk about the truth values or the statements, sorry, the truth tables of each of these connectives or these compound statements. So let's draw 45 of them. So far we've covered, the first one we've covered was conjunction. We've covered conjunction, we've also covered disjunction. We've covered implication, equivalence, and all the rest. So let's start from the first one. For conjunction, which is this and, let's have the truth values. Imagine we have the first if we have the first instance as true and the second as false, or if we have the first instance as false and the second as true, or if we have the first instance as true and the second as true, or if we have the first instance as false and the second as false. So that's TF. So let's talk about what will be the result. This is called a truth table. So if you have your first statement as true and the second as false, so when you combine those together, just like when you are combining operational amplifiers in electronics, so that's more advanced, but it just simply is based on this combination of AND gates, NOT gates, and OR gates. That is computer, but we will not be dealing with that in this video. So now, when you have in a conjunction statement simply means that your result is a combination of the two. So that is true and false is what? So it is only true if both are true. So if one is true and the other is false, then it is false. If one is false and the other is true, then it is false. If both are true, it is true. Then if both are false, it is false. So an AND statement requires that both your statements have to be true in order to be true. So if both your statements are true, then your conclusion will be true. So the conclusion of an argument is the final statement or the combination of the simple propositions. It gives a conclusion, which is the final statement. So this is the conclusion part, and these are the first two simple statements. So it's only true if both your simple statements are true. Otherwise, it is false. It's obvious from the table. Moving on to the disjunction. Which is this one, this sign. This is a normal V, an upright V. So we have true, true, false, false. We have true, false, true, false. So these are the two simple statements. So what will be the result of each of these? So now if you have, now this is an OR connective. Now this is an AND, AND connective. Why this is an OR connective? The upright V is an OR connective, while the inverted V is an AND connective. Now in this upright V, which is the OR connective, it means that either one of them is true or the other is true. So if at least one of them is true, it will be true. So that is the OR connective. So if you have at least any true here, it will be true. So this one you have both true, so it will be definitely true. This one you have one true. So I said if at least one is true, your conclusion will be true in an OR connective. So that means that will be true. So this one, at least one is true, that will be true. But this one, none of them is true, so it will be false because there is no true. That is the OR connective. Then thirdly, let's go to the negation connective, which is this symbol here, by this curly and wavy symbol, just like the symbol for alternating current in physics. Now moving on, this has a truth value. If this is true, true, false, false, the first simple statement, then we have the second one that's true, false, true, false. Sorry, it has only one statement. It doesn't have to do with two statements. So what's it called? The negation connective has to do with only one statement. So the negation of a statement is not. So the negation often works for one value. So negation has not like two values, or like connective. This first two connectives, but the negation only has one value. You can see only 2 columns, but the first two has 3 columns. So that's the difference. For this negative, it has only one, and it is the opposite of that one. So for if you have your simple statement as true, then the negation of that simple statement will be false. If you have it as true again, it will be false. If you have it as false, it will be true. If you have it as false, it will be true. So your negation statement is just like the opposite. If your input is true, your output will be false. If your output is false, Sorry, if your output is false, then your input was true. If your output is true, then your input was false. So if you know your input, you will know your output, because it's always the opposite or the negation of the simple statement. So moving on to the next connective, which is number 4, which is the implication. Implication is represented by a forward arrow. So this simply means that if you have a first one, what this means if you have A implies B like this, it means if A then B. If you have B implies A, it means if B then A. So that's what it means. So the truth value of this one will be true, true, false, false, true, false, true, false. Let's convert this into a truth value. Now this is true and this is false. False and true, false, true. This is true here, this is false. Now in an implication is true only if both are true, your implication will be true, because if A then B, it means it is true. So an implication is true if both are true here. Now next we have if the first is true and the second is false, it will be false, because an implication is only true if at least your last one, if at least the second statement is true, then your implication will be true. For this one, if at least the last statement is true, your implication is true. So always remember that. This one now you can see that the last statement is true. So this is first is true and the last is true. So for the conclusion to be true in the first place, the last statement should be true. So this true and true will give true. This true and false, where the last statement is false, will be false, because the last statement is not true. This false and true, even though the false is true, even though the first is false, but as long as the last is true, we have it as true here. But then if both of them are false, then it is false. That is one property of the implication table. So true, false, true, false. That's how it goes. Then we have the equivalence statement, equivalence truth value. So we have true, false, true, false, true, true, false, false. So for this equivalence statement, an equivalence statement is true only if both your values are the same. So if you have the same, if the truth values of both statements are true, then your equivalence conclusion will be true. For example, if both are true, it will be true. If both are false, it will be true. But if they are different, if one is false and one is true, it will be false. If one is true and one is false, it will be false. So your equivalence statement is only true if both the truth values of both your simple statements are true. So if both are false, it will be true. If both are true, it will be true. But otherwise, it's false. So having got to that, so